Hey, it's Luke. Today on AutoDarts, I'm going to show you how to install our MOSFET motor span board into a standard stryfe. Let's get going. Simply put, a MOSFET is a way of switching high current power, such as your flywheel motors, with low current wiring, such as this itty bitty wire here. The great thing about using a MOSFET is that you can fit wire in places you normally couldn't, in blasters like a demolisher where there's not a lot of room to get the wire path through. Additionally, it also avoids having to replace the switches, so we can keep the stock switch that's in this stryfe when we do this mod. Now, the board itself is very simple. You are going to simply choose whether you want to use an XT60 connector or you can solder directly to the positive and negative. But you're either going to solder another XT60 to mate up with this and then solder this to the board, or you're going to solder directly to the board marked positive and negative. In similar fashion, the motor terminals are marked. This is positive, red, positive, so that will line up with your dots on your motors, giving you the correct rotation. Now it's worth noting that the XT60 connector needs to be down next to the cage, and we'll show that in the install guide as well. These are really handy. They are probably the easiest way to get started in modding a blaster. One of the reasons being you don't have to mount switches, and this simplifies motor wiring. Now, some of you are probably scoffing at this as a product, but I will tell you there is definitely a case for this because not everybody is really confident with soldering, and soldering to these little terminals makes it very easy. Additionally, I've also designed these simple little 3D printed shims that go on top of the motors, and what this allows is it will stop any solder from touching your motor can, which can cause a short, and that is one of the #1 things I see from new modders is a little too much solder being used and having it drip down. These are just made of PLA plastic, but for a quick contact and just a little isolation, they work just fine. They are not totally necessary. If you're careful with your soldering, you can certainly do without. They're not a requirement, but we do include them at no cost. Additionally, you've got two options with the switch. There are two tiny terminals here. All you need to do is connect them to turn it on and off, and that will activate the blaster. We do sell these JST 2mm spacing connectors, JST PH connectors, and you can choose to solder these directly onto the board like that, and just two little dips of solder there will do it. And at that point, you have a plug-and-play option where all you do is plug this in, you solder this to your switch directly or to the switch leads, whichever is more convenient, and you are golden. So just to be clear, to do this mod, you have to solder 1, 2, 3, 4, 5, 6, 7, 8 points, and that is it. And they are all very forgiving. There are no helping hands generally needed, and that's pretty much it. So let's get going and we'll dive right into the stryfe and show you how this is done. This will be a very quick tutorial, and I'll pretty much just cover the installation of this and not cover anything about the normal upgrade paths such as flywheels, but I am going to use upgraded flywheels and an upgraded cage. This is, however, compatible with stock cages. It's compatible also with every single cage I sell on the shop and virtually every flywheel blaster because of its low profile. There are a handful of blasters where this modular XT60 connector will not work, and you will have to solder directly to the motor terminals there, or the battery terminals, excuse me. All right, so we're going to dive right into the stryfe. I'm going to run you through the parts you need first really quick. You're going to need basic tools like a screwdriver, potentially a Dremel or snips to get your battery filled out. We're not going to cover a full mod here. I'm just going to show you the basic setup of installing this board. You're also going to need a soldering iron, solder. You're going to need a cage of some sort. I'm using this prototype Heston cage that they sent me a while back, and I've been wanting to put in a blaster. I'm going to use two Fang motors. I've got the board with the spacers, my flywheels of course, cage screws, this JST 2.0 connector, my XT60 connectors, one for the board and two for the coupling of the board, and the last one is for the actual battery connection. Of course, safety glasses, and that should be about it. This is a blaster that was basically stock. It's been rudimentary it's been very crudely rewired to use a set of high drain night core batteries. Now we're going to upgrade this a bit and go to LiPo, as I run pretty much everything off LiPo, but I did do some extensive testing to see what could be done in the IMR world. That's another video. So I'm going to get this all out of the way and we're going to dive right in. First, we're going to go ahead and get our cage set up. This is the probably most important part here. And the key here is that this obviously sits in the blaster like that. And we want to ensure that we actually get this connector facing backwards, because if it faces forwards, there's not enough room to actually run the wiring. Now, if you're going to use this connector, you can just hook this on and you're going to solder this in place. I like to do this first, but if you don't want to use this connector, then your battery connections will solder right to these 2 points. But I'm going to show how to do both options. So we're simply going to plug that in, and the main solder point we're going to solder is right here. So you just want the solder to flux through the entire port there, the joint, and you'll feel it when it goes totally liquid. You're good to go. So that's all we need to do there. Connecting these back 2 pins is optional. They are not needed to hold it on the board. They're really just more about placement. So you don't actually need to solder those 2 small points there. Now that we've got the battery connector set, we can actually get our motors in our cage. One thing you have to know here is that the alignment does matter. We're going to match red to red, and we're going to match red to red over here, so they alternate. So what you need to do is look at your cage, how that's going to sit in there, and make sure that you've got your motors placed correctly. So that's how I'm going to have this set up, and we should be good to go. This is always a fun trick. Whee! So with that, you'll just want to go ahead and Loctite your screws in like you would any other cage or whatever cage you're using. So now I've got my cage ready to go. So this is where you'll want to start off. And the next step is we're going to throw these 2 little spacers on here. Again, as I mentioned earlier, these are completely optional. They are nice and tight. They will kind of lock onto the collar here, the back of the actual motor. Does not matter which way you put these on, though there is a orientation so that they sit straight, though there'd be nothing wrong with putting them on like that either, to be honest. They are simply there as just an extra precaution for insulation. Now that we've got that on, we'll go ahead and we'll just drop this in place. And then we're going to solder each of the 4 terminals in place. I like to just use an extra finger there to hold that on. Now you can put a lot of solder on here, you can put a little solder on here. It really doesn't matter, but you don't need more than about that. But if you like to fill the whole cup, go ahead. Not going to hurt anything either. I will say that less can be more if you ever think you might need to remove this, like for burnt out motors or something like that. One thing to note about this board is that this won't save you from stalled motors killing themselves. And if you do burn out a stall, like a full stall, and you hold it, you will pop the MOSFET as well. It is not current protected in any way. We might look at adding that on a feature and some more advanced boards where the cost of the board is higher, but for now we didn't really see that as necessary. Now, depending on what you're doing with your switch, you have 2 options, and you can either just simply wire 2 little wires directly to the switch, or what I'm going to do in this case is actually connect this jumper. And I really should have done this earlier, but it'll be fine to do it now. It might just be a little harder to see, but basically you're going to plug this in. Polarity doesn't matter. This does sit one way a little better than the other. This is intended to go on the bottom side of the board, so like I should have put this on first. So what I'm going to do in this case is I'm going to plug this in and put it on the bottom side of the board. The polarity doesn't matter at all because this is just a switch, because essentially bridging those 2 contacts will turn the MOSFET circuit on and activate your flywheels. So it's a little hard to see, but I've basically got that pin going up and through, and now I'm going to just solder the pins on those. Again, you can just solder wires directly to this. There's no reason you have to use these connectors. And as you can see, I was able to do this pretty fine with a fairly large tip. I'm trying out a different tip here, and you'll have to excuse my shaky hands. Recording in the morning after 20 ounces of coffee is maybe not ideal. All right, so now that we've got that basic wired up, you've essentially seen everything you need to know to install this. The battery connection can go from a normal battery connector like you would an XT60 and create a modular component on the other end, so a wire would run through the blaster to bridge that. Or you could solder again directly to these terminals. But since we do have this fully set up, I can actually plug this in. Again, flat side is positive. You'd want to make sure that's lining up with your positive. Make sure you didn't do the connector backwards and have the board flipped. That would be a problem. And now, in theory, if I just touch these two contacts together, we should see this rev up. Let's see what happens. And it does indeed. So we are set up and working. Now these are a pair of fangs, but these are some pretty heavy wheels, so you can actually hear that sort of rev to start up. But it's a nice, quiet, balanced wheel set and cage. I quite like it, so I'm going to have some fun with this in a blaster. Next, I'll put this back in the stryfe, but honestly, if you know the rest of modding a stryfe, this goes to the switch, this is your power. Couldn't be much easier. But let's get to the rest of the stryfe. So back to the stryfe here, we now can pull out our stock cage. And in this case, I'm going to clip these two wires up here off of the cage. This has been wired slightly differently, but essentially all we need from the stock configuration is the two leads going from the switches. These two leads going from the switches are the ones that are actually going to connect to our MOSFET circuit. Now to fit this board in here, generally, this one included, I am going to need to clip out or grind down these four components. I show this in my Nerf book. It's really quick and easy. So if you're still with me, I'm glad you are. Another part we're going to clip out right here is, I'm going to clip out enough space here for the XT60. This doesn't have to be very perfect. You can be pretty approximate with it. But when you place the cage in, you'll understand pretty quickly where that's going to need to go. So I'm going to get everything set and in place. I've got room for the XT60. I'm just going to check. Yes, indeed. And while it may look like the XT60 is going to be in the way, it's actually fine because of where the magazine seats. If you are still with me here, I'm glad to see you still watching. I always struggle with making videos, whether they are for an advanced modding audience that has all the baseline knowledge, or if they're for a first-time user. And it's a kind of a tough decision as far as how to handle that, because I don't want to bore people that already know the info, but I also don't want to leave people high and dry, not knowing what to do. So I'm going to go ahead and solder up, make sure I get them long enough. This is going to be more or less an XT60 battery extension here. So I've got some 16 gauge wire, but you could use whatever gauge you want. 18 would be fine for this too. The runs are short enough, but I tend to like working with the 16 just fine. Now, I will use helping hands on this part. Remember that your flat side is always your positive. Now that I've got the XT60 connector done, I'm going to put heat shrink on both terminals. And this is just one end of the XT60 connector. Now this connector can get connected to our flywheel set and routed up under like this. And the 16 gauge wire will fit in here. In fact, it actually works as a pretty nice retention. Now we do sell an expanded wire channel that will fit here, but I will warn you that with these extra connectors, it's a little more tricky. You can negotiate this however you like. What I'll frequently do is cut a little extra path here to allow for those wires to get through, but you can negotiate this through here however you like. All right, so I'm going to go like that. So now that I've got that 16 gauge wire there, we also are going to send our switch wire back, which we are going to connect to our switch or to the switch wires coming from the switches. Normally I would use the expanded wire channel meter for this, but in reality, as long as I can get this in here and held, we should be just fine. Also got to work on these autofocus settings. Sometimes my camera does not want to keep me in focus. So this is a little quick and dirty. I might normally take a little bit more time to clean that up and use the expanded channel to make that fit. But what you can see if you take a magazine and test, you've actually got tons of room there as far as spacing. So that is now good to go. The last step is literally feed this out into your battery tray, wire up this XT60, and connect these two to your switch. They're not going to reach here perfectly, but they are going to reach the wires that were pre-existing here. So we're essentially going to pull those wires up. We'll clip off the battery terminal, and this would be the same if this is a stock wire. In fact, this one here actually is the stock wire. So our last step here is to wire up our XT60 connector. So normally you're going to do your battery tray cutting on the other side of the blaster to fit in your XT60 connector and your battery. I recommend the 950 graphene for strifes, as it's a really easy fit in there with a LiPo alarm compared to a lot of other packs. But essentially, we're going to connect this to an XT60. So I'm going to make this long enough so when I feed it through later, it will be just fine, something like that. I'm not going to show how to do the dremeling and all of that. That's covered in my Nerf book. It's also covered in a lot of other tutorials. However, if you guys are really interested in a stryfe tutorial, I could put one together in the future. Right now, I'm kind of more focused on new blasters. Since there are fewer tutorials out there, I feel like it's more value added, but I would love to hear your thoughts in the comment as far as what you'd actually like to see. And of course, we're going to throw a little bit of heat shrink on each side. Get the XT60 wired up. Still working on this camera setup. I'm building a whole custom table that'll be next to my photo table so I can swing the same light around and use it for all of my setups. It should be really, really nice. Key to shooting a lot more videos is really just having the right setup. Setting up for this video took me about an hour and a half, and that's not including the actual mod components and scripting and trying to figure out what I wanted to talk about. So it's a work in progress here. We're definitely getting more organized now that we are back to work. I hope you're all home and safe and healthy. And hopefully we can all get back to somewhat normal life relatively soon. But at least there's Nerf modding and other hobbies in between. So now that I've got that done, I'll go ahead and slide my heat shrink up on there. If you do it quick enough, you can kind of get it to melt or hold in place. But of course, and as I've mentioned in my other videos, I generally will take a piece of 1/2-inch heat shrink, a large piece, and put it over here as a covering. Kind of a nice final touch. So now that we're here, we're basically going to take our two switch wires, doesn't matter which two, and we're going to connect them to our switch. Since my wire is a little bit too short, I will be selling longer versions of these so that it does reach all the way. We're going to basically solder these together. Really, really simple. It doesn't matter which one. It's simply an on-off switch. It's also effectively the same as just touching these two together. But on a normal stock blaster, you could just reuse the wiring that comes on the blaster, connect that to the MOSFET. That would be just fine. And we're just going to do a quick little wire twist there and then bridge these together. There is so much cool stuff happening in Nerf right now. As I'm finishing this up, Drac just released his Pariah blaster, the fish blaster. It looks really cool, bullpup, solenoid driven. I will hopefully be one of the earlier ones to get one of those because solenoids are super cool. I love the stuff that Drac does, and I love seeing more blasters out there. Another part of my setup here that's a little awkward is just trying to get my head in the right place, so I'm going to have to work on a way to do this where my head doesn't bump into frame as I'm filming. All right, now that I've got that done there, I'll go ahead and heat shrink those up. Again, normally I'd probably run one wire all the way through, but for illustrating the use of this is just fine. Then at that point, all you'd have to do is actually route your wires where you want them to be. I'm not going to worry too much about that for the sake of this, because this is really just a demonstration of this board. And obviously we would want to, of course, put our switches back in. But there we have it. That is it. Now I can plug in my LiPo. When you plug in your LiPo, I'll show you the other side of this board. You won't see the light turn on until you hit the switch. But then when you hit the switch, you'll hear that light pump on. So this is effectively done. We've modded a stryfe using this board, and pretty quick and easy, to be honest. And since I'm going to probably put a short dart kit in this blaster, there we have it. It's really quick and easy. It's a nice way to mod a blaster when you don't have a lot of space for wiring, or perhaps you don't want to rewire the full blaster. You have a lot of options as far as how you hook this up, but it's really relatively simple. And again, everything is labeled, so if you follow the directions on here, you'll do just fine. Let me know what you think of this product. This is something we're going to keep iterating on. Thank you so much for watching. I hope you enjoyed this video. We are going to have a lot more PCB products and smart boards and other things coming this year. I'm working with an engineer friend of mine who has been really, really amazing in getting some of these products put together based on my design and testing and my needs. So expect a lot more out of us this year. Thanks so much for watching. Do hit that like and subscribe button. It helps out the channel a lot. Until next time, I'm out of darts.